trigonometric functions and transformations of the sine function and cosine function when they're combined. Remember, vertical stretches are determined by the value of A, and we typically combine them when we're graphing with a reflection in the x-axis if it exists, a reflection in the x-axis if it exists. And we graph them together by multiplying the y values of the parent function by A. Now, the graph of sine x or cos x is vertically expanded by a factor of A if the absolute value of A is greater than 1. That means it's distance from 0. So if A is -2, it's 2 away from 0, which would mean it's a vertical expansion. If A is -0.25, it's 0.25 away from 0, so it's a vertical compression. Okay, and the thing to note when we're dealing with reflections, for sine and cosine, the max and mins trade locations because, of course, they're being reflected. Vertical translations are your up and down motion, okay, and they change your equation of your axes. And if the C value, the number tagged onto the end of the expression, is positive, you're moving up. And if it's negative, you're moving down. Phase shifts are determined by the value of the D, the part inside the brackets with the angle. If it's negative, you're moving to the left. If it's positive, you're moving to the right. Sorry guys, we don't have the whole page showing up here. Okay, now transformations of the sine function and the cosine function are exactly the same as the transformations we did of quadratics. We always stretch and reflect first, so we multiply the y values of the parent function by A, and then we do our horizontal and vertical translations. So we're shifting the graph of f at x is A sine x, left and right, and up and down based on the value of C and D. We're going to do a table just like we did with quadratics. Okay, and we're going to talk about what the amplitude, the period, vertical translation, phase shift, and the reflection are. Now keep in mind, the only thing we have graphed is a period of 360 degrees for the sine function. That's never going to change in this course. The number in front of x, right here, is always a 1. Okay, and that's important. If that changes, the period won't be 360 degrees, but we don't graph functions that don't have a period of 360. The amplitude is determined by the coefficient of the sine or cosine function, and we don't use the sine of it. So in the first one, 3 sine x minus 3, the amplitude is 3. In the second one, 6 cos of x minus 360, it's 6. The third one, -2 sine of x plus 180 degrees plus 3, the amplitude is 2. The negative is not part of the amplitude because remember, amplitude is the distance or half the distance between your maximum and minimum. And the last one has an amplitude of 5. Vertical translations, are we moving up and down? Sure we are. We've got this lovely, oops, sorry guys. We have that lovely -3 right there. That's telling me to move down 3. There's nothing added to the next one after the brackets. And this one here, I see a +3 and a +1. So when we talk about the vertical translations, in the first one, it's down 3 units. The second one, there is none. Make sure you tell me none. If you leave it blank, I don't know if you understand that there wasn't a vertical translation. Up 3 units, up 1 unit. Phase shifts, we're looking at what's inside the brackets with the x. And if I look at that, in the first one, nothing's in there, so there is no phase shift. In the one where we have x minus 360, that's right 360 degrees. X plus 180 is left 180 degrees, and x minus 45 degrees is right 45. And reflections, well, the only one where we talked about the amplitude being positive or negative, and we had to discuss that the amplitude is always positive, was that one there, -2 sine of x plus 180. So it's the only one that has a reflection. And we have to be clear to say that the reflection is in the x-axis because reflections can occur in the y-axis. We just haven't learned them yet. And without graphing, can I find the maximum and minimum values of y equals 3 sine x minus 3? And that's the really important part. It says without graphing, so I'm not going to do any transformations. How do I figure that out? Well, I know for the sine function, the maximum is normally 1 and the minimum is -1. So if I start with a 1 and a -1, when I deal with this 3 here, it's going to turn into a 3 because I'm expanding by a factor of 3, and the minimum is going to turn into -3. And then everything has to go down 3. So what's going to happen next? 3 take away 3 goes to 0, and -3 take away 3 goes to -6. And my maximum is 0, and my minimum is -6. And the last thing we're going to do is graph it. So generally with sine and cosine, I don't graph the base function because it's very easy with patterning to put that stretch and reflection in. So we're going to start with 0 and 360. We're going to graph that first. And then what are we going to do here? We need to put the other 0 on, exactly halfway between them. And exactly halfway between the first two, I hit my maximum, which in this case won't be 1, it'll be 3. And the minimum in this case will be -3. And I draw a nice smooth curve through them. And I've now graphed y equals 3 sine x. Now it tells me to move everything down 3. Again, not so hard. Take this and move down 3. Take this point, go down 3. And take this point, go down 3. Take this point, count down 3. Take this point and count down 3. And I draw my nice smooth curve through everything. And I'm done. What is the domain of this? The domain isn't that hard. What I graphed started at 0. And that's less than or equal to x, less than or equal to 360 degrees. If I'm doing for one cycle and I haven't shifted left and right, my domain will stay the same. My range, I actually found out on the page before that it goes between -6 and 0. And I have to say it's an element of the real numbers. I don't know why I didn't do that. The equation of the axes is interesting. Where did all my zeros move to? They all moved to y equals -3. So that's the new equation of my axes. And my amplitude, we've already discovered, comes from that number in front. So the amplitude is 3. And of course, this is much prettier on this page for you to look at and copy later. And hopefully you will complete pages 9 to 10, 1A to F, 2 and 3 before class tomorrow.